Okay, for the stem and leaf plot problem we have in number 27, okay, we have the minimum values at 15, maximum value is going to be at 98, and including all the other values in between. Okay, we have for the stems, we have running from 1 to 9, those representing the 10s, 20s, 30s, 40s, 50s, 60s, 70s, 80s, 90s, and there were 25 data items, and arranging the leaves or the unit digits in order from smallest to largest. Okay, this would be the layout for the stem and leaf plot. And in terms of what we have for the double stem plot, okay, notice that there's nothing in the lower 10s, okay, nothing 14 and under, so we'll start out with the mid to upper 10s going all the way up to the upper 90s. And so in the case of what we have for the double stem plot, okay, we have the numbers arranged as such. And so for what we have here, okay, the double stem, okay, we have, okay, notice we have 15, 19, nothing in the lower 20s. Then we have 26, 28, 31, and then we have in the mid to upper 30s, we have 35, 38, 38, 39. Going down, we have upper 50 number missing. Nothing is present in the lower 70s, nor is there anything present in the lower 80s, nor is there anything present for the lower 90s. And so this would be the layouts for the double stem plot, again starting at 15 and then going up to and including the number 98. Okay, now in what we have regarding the various ways of looking at mean, okay, we have the determination of mean when the only items we have presented before us is a frequency distribution. And we have a case here where we have classes, okay, ranging from 150 to 158 all the way up to and including 204 to 212. And we have for the corresponding frequencies, we have 5, 16, 20, 21, 20, 15, and 3. And now it asks for both the mean and the modal class. Modal class we can get to very quickly, and that is going to be that which has the highest frequency value, which we have at 21, and thus the modal class will be at 177 to 185. Now, in configuring what we have for the class midpoints, again, that will be taking the mean of the lower and upper class limits. So we have a class midpoint at 154, okay, and then maintaining consistency. Again, we had the class width at 9, transition from one lower limit to the next, upper limit to the next, and also from one class midpoint to the next. And so the highest of the class midpoints will be the mean of 204 and 212, which we have at 208. Now on to figuring, okay, what the mean is going to be. And so we have for the numbers, we have the frequency times the midpoint. Okay, so we have for the first class, okay, we have frequency value of 5, midpoint is going to be at 154. Next class we have 16 for the frequency, midpoint we have at 163, and so the recorded product of the frequency and the midpoint we have at 2608. And continuing the trend, okay, the sum of the products of the frequency and the midpoints will be at 18,028, and in the determination of mean itself, that is going to be the ratio of the sum of the products of the frequencies and the midpoints divided by the number of items, which we have to be at 100. And so looking at the ratio of 18,028 to 100, okay, we have, and this is the mean value, you can say it's going to be at 180.3. Be sure to keep all the decimal places. We have 180.28, and once again we have for the modal class, that will be at 177 to 185, again since we had the highest frequency recorded for that numerical range. Alright, now in what we have regarding the determination of mean in the context of weighted mean, again we have for our two problems in numbers 26 and 29, okay, we have in this setup, okay, we have for 26 we're looking at mean price, okay, of automobiles, and again we have for the algorithm, you have the sum of the products of the weights and the respective values x over the sum of the weights. And again for x, you're looking at price, x without the bar over it. Okay, that is just taking the itemized price amount. So at $10,000 you have 8 sold revenue generated we have at $80,000. Then we have 10 automobiles priced at $12,000, 12 automobiles priced at $8,000. So you have the subsequent revenues at $120,000 and $96,000 respectively, and the number of autos sold we have at 30, and the total revenue generated we have at $296,000. And so looking at the mean price, you're looking at the ratio of the total revenue over the number of autos sold, and so we have for the mean that is at $9,866 and about 67 cents. And in the case of what we have for houses, okay, there are 27 houses, and okay, where we have 12 sold at $725,000 each, 6 at $365,000 each, and the 9 houses we have at $427,000. And with the product of W and X, we have the respective revenues. And so for here we have the mean cost to determine. X is reference to cost, and X itemizing. Again, we had these three values: $427,000, $365,000, and $725,000. And looking at the number of houses sold and the revenue, we have for the sum of the products of the number of houses W times the price of each house X, have the sum at $14,733,000, and dividing by 27 number of homes sold, we're looking at a mean cost of each dwelling at $545,666, and again about 67 cents.